Hello again guys, so in this video we'll talk about arrays. Now we have talked about arrays briefly in previous videos, alright, although I guess we only covered the basics. So in this video, we're just going to cover more. Again, we'll cover how we declare arrays, how we assign values to them, alright, and then also additional things. For example, how we can search, so specifically using linear search. We're also going to look how we can count the number of occurrences of an element within an array. So if we have, for example, like people, this could be sort of just names or usernames, maybe email addresses. Alright, we might want to count how many times that username or that email address appears within the array. Similarly, we can also find the index position. And in fact, let me make this a little bigger. Right, so for example, again, let's say we're searching for a specific username. Well, maybe we just want to find if if that username exists or doesn't exist, right? But we might also want to find the position that the position that email address appears in the array, right? If we've got numerical data, well, we can find the minimum, the maximum, right, the mean, and the sum. Now, I guess you could also extend this. You could also find the mode, the median, maybe the standard deviation. All right, although those things will be a little bit more difficult because in order to find, say, the mode the mode and median, then it will actually require that the array is sorted. So I mean, in order to sort it, well, one method we can use is bubble sort. All right, so we'll also look at this. And I mean here, we'll just look at a lot of examples. All right, we'll also look at ByVal and ByReference. Now, we also talked about this before. Again, we'll also cover the difference between local and global variables. And I suppose if we've got a global array, then that's going to be quite easy to directly access and directly modify. And the thing that's quite lucky as well, in the exams, usually they'll just give you a global array. Right, although sometimes they will actually want you to pass it as a parameter, and if you're passing it as a parameter, well, you're either going to need by value, which is the default, or you can use by reference. I mean, again, obviously in the video we'll talk about this, but just quickly now. So by value, this will actually create a copy of the parameter as we pass it into that module. So either function or procedure. Now, I mean, okay, sometimes this can be good because, well, since you have a copy, then this means you can actually change this, and then the original is going to stay unchanged. So like in some situations you might want that, okay, if you don't want to modify the original. However, other situations, well, you will want to modify the original. You don't need kind of like a temporary copy, or you don't need some sort of copy that's just used for processing, right? I mean, you just want to directly update the original, right? And well, that's where you can use this ByRef. And then again, we'll just look at some examples here, all right? And also using one-dimensional arrays, so just a list, and then we'll also look at a 2D array. Alright, so I guess first, well, let's just declare a simple array. We can probably have this maybe scores or just numbers. So again, if you remember how to declare variables, right, we just use the keyword declare. Let's call this scores. Again, we just use the colon to specify the type. Right, and I mean here, like, whereas usually we would say integer, well, in this case we're actually going to say array. Alright, and then what we need now, we actually need these kind of square brackets, and then we say the starting index and then the ending index. So in this example here, we're saying, well, the array will start at position 1, okay, then it's going to end at position 5. So in other words, there's actually going to be 5 elements. Now, I mean, most programming languages, they're actually going to start at 0. So most programming languages, 0 to 4, right? That would mean there's 5 elements. But in pseudocode, well, let's start at 1. Now, if you really wanted to, you could literally go 7 to 12 like this. Okay, this will also work, and this will also be 5 elements. However, I think, well, really, it's going to make logical sense. All right, just start at 1. Anyway, so then we just go of, so, and then here is where we say the data type of this array. So here I'm just going to say, well, scores, I mean, yeah, they're just going to be integers. Now, you know, if it's a real game, or maybe you could also have a real. However, for me, right, I'm just going to keep it simple. Because, yeah, I mean, well, actually the code is the same anyway. So, alright, so yeah, let's just assign some scores. So again, there's two ways to do it. Now we can actually take this, well, we can take the whole scores array. And then, for example, well, let's just go like, yeah, 1, 2, 3, 4, 5. Just something quick. Alright, and then, I mean, if we run this, yeah, I mean, you see we get no errors. Now, what I'm going to do is, well, I'm just going to have a quick for loop, just so we can actually output these, just to see. So in order to loop through an array, well, we can just use a for loop like this. Right, then we're going to say n, so this will be the count variable. Now what we need to do, well, this n, right, this should start at the starting position of the array, right, or the starting index. So here it's just going to be 1. Right, and then we're going to say 2. And yeah, I mean, here it's just going to be the ending index. So we could say 5 like this. However, the problem is, let's say someone changes the size of the array. Well, now if we're only going to 5, you know, then it's only going to print the first 5 elements. But of course, if we had more like, say, 6, 7, 8, 9, 10, well then, of course, I mean, here, if we're going to 5, right, it's going to print these, but I mean, it's not going to print these. Yeah, I mean, so, well, let's do this just to see, right, and then let's see how we can kind of improve this a little bit. Right, so in order to output, let's just go output like this. Then we say scores, so the array. However, well, in fact, let's just try. Right, let's go next n. Right, however, this should... okay, alright, yeah, sorry, this should actually give us an error. So let's just try and run this. Yeah, okay, so basically it's saying, well, can't convert array scores to string. Right, and the reason it has to be string is because, well, I guess this output is going to output a string. Yeah, okay, so, well, here, I mean, it gives us a bit of a hint, right? So to access or output specific elements, you will need to loop through the array. So e.g. output scores 1, right? So what we actually want to do, well, we actually want to go scores n, right? Because again, this n will start at 1, right? The next loop it will become 2, then 3, then 4, then 5. So this should output the first 5 scores like this. And yeah, okay, we can see this is working. Now, again, the problem is, I mean, like I said, this is fine if we know the end index. But for example, let's say someone changes this, like, and I guess here it's going to be even worse. Right, so if they make it 3, well, this should output the first 3, right? But then, yeah, then it's actually going to give us an error. Or in fact, actually, sorry, I mean, this, yeah, this, okay, this assignment will give an error, because we're trying to assign 10 elements, right, to an array of size 3. Yeah, I mean, so here, if we see this, basically saying scores 4 is undefined, and then, yeah, ensure the index, right, and or member attributes are valid. So when we're saying the index, well, the index just means the position, right, the position in the array. Yeah, so of course, you know, we can do that. But again, right then, here, if we go 16.5, right, well then this is saying index 4 out of bounds, because, I mean, here we've only got 3 elements. So again, I mean, let's just say 5 like this, and again, let's go 4, 5. Alright, and then, I mean, really the way we can solve this is we can just use the length. So like we see, this length, well, it takes either a string or an array. So if it's taking a string, well, it's just going to count the characters. So I guess, yeah, this happy days, this has 10 characters. Alright, however, if the argument is an array, well, then it's just going to count how many elements are in the array. Right, so in this case, it's just going to be 5. So yeah, I mean, think, right, so 1 to 5, right, this is the same. It's just, well, 1, 2, right, length of scores. Because, yeah, I mean, here there's 5 elements, right, in this array. And then, yeah, okay, so here we can see this is working. Alright, so actually I'm just going to give these some random values, or in fact, yeah, okay, so actually let's just assign them some random values here. Alright, because, I mean, there's actually a few ways we can assign to arrays. So we can do it all on one line like this, However, I think Cambridge, they actually don't like you to do this, right? They would actually prefer you do it like this. So for example, well, we do each one individually, right? So we say scores 1, and yeah, I'm actually just going to say rand. And let's say this can be a random number. Yeah, let's say from, well, so this will go from 0 to 9. All right, and then yeah, I'm just going to copy this. All right, so yeah, let's go 1, 2, 3, 4, 5, and okay, so here we go. Right, and then let's just output them. So this should also work. Right, and then here they should all just be random numbers. And yeah, we got what, 9, 6, 7. And then if we try again, right, you see we're going to get different numbers every time. So, I mean, this does work. However, let's imagine this was 500, right? Well, we wouldn't want to, you know, manually copy this 500 times. So in that case, I mean, we could actually assign within this loop. All right, so what I'm going to do, I'm just going to copy this. Right, so let's make this scores n. And then here, well, okay, we're going 1 until 500. Right, yeah, let me just delete those. So we're going 1 to 500. And then in each of these 500 elements, okay, then we're just inserting. Yeah, or then we're actually assigning, you know, a random number, right, between 0 and 10. Sorry, okay, between 0 and 9. Yeah, to the actual scores, right, you know, at the specific index position. Now, of course, I mean, we can just go here like this, and then we go output, and then we can just go scores n like this, right? This will show us. Yeah, I mean, however, I'm actually going to do it just in a separate loop, you know, just so we can see this has actually done, yeah, every single one. All right, so what I actually want, I'm going to say I want output, and then I'm just going to output n, right? Then let's just concatenate like this. So yeah, this should go like sort of 1, then the brackets, all right, then it's going to be the scores. So yeah, let's see if this works. And yeah, okay, so we see, right, 1 is going to be 2, 2 is 3, 3 is 9, and then it should go, yeah, okay, right, so all the way to 500. Right, so hopefully that makes sense, you know, how, again, how we can declare arrays, how we can assign to them. So, you know, well, I guess kind of 3 different ways, right? So again, we could just go scores like this, and then of course just have the array, and then yeah, just kind of manually type them, right? The other way is where we have to do each one individually. So for example, we have index 1 can be maybe 7, right? Then we copy, go index 2 can be 8, right? So on. I mean, or if we've got, lots of them, and particularly say if they're integers, or yeah, if we can sort of generate random values. Yeah, or if we're reading from a file, right, you know, then we would probably want to assign to them kind of inside a loop. All right, that's just going to make it easier. Yeah, it's going to make it faster. Okay, so I mean, yeah, now we've actually got this, and I'm just going to make this a bit smaller. Let's go to 10, and yeah, okay, I think that's fine. So let's say what we actually want to do. We actually want to search to see if a specific element exists in this array. So I'm actually just going to have an output. Let's say, yeah, please, yeah, I'll name please enter a number. All right, so then the user is going to type in a number, right, and then the program is going to tell us if that, you know, if that number exists in the array. Right, so yeah, let's actually, I mean, okay, so well, yeah, we're going to make this a function basically. All right, so we'll make a function called linear search. But before we do that, let's just create a variable just to store the user's guess, yeah, or the user's number. So let's call it user input. All right, this is going to be an integer, and then here, right, let's go input, and we'll just store this in the variable user input. Right, now I'm actually just going to pause the video, and I'll just show people how to do linear search. Yeah, in case you're not familiar with this. Alright, so let me just write this here then. So if we want to learn linear search, and yeah, kind of excuse the handwriting, this is a new graphics tablet, I'm just kind of getting used to it. Alright, so let's say then we've got an array, and I'll just draw these square brackets like this. So maybe we've got the values 4, right, we've also got the value 7, or let's say 8, 2, and then let's just say 3. Okay, 3, there we go. Yeah, and again, kind of excuse the terrible handwriting. Right, so let's say we're searching for the element 5, right? So, I mean, obviously, we can look at this, we see 5 doesn't exist. So what we're going to do, well, we're just going to start on element 1. And in fact, let me just change the color here. So we're going to start here at sort of element 1, right? And then we see, well, is 4 equal to 5? Right, and then in this case, right, this is going to be no, it's going to be false. So because, right, 4 is not equal to 5, well, then we go to the next one, so 7. I mean, then we just do the same. So we say, is 7 equal to 5? Right, again, false. Of course, go to the next one, right, 8 equal to 5, right, no. Is 2 equal to 5? No. 3 equal to 5? No. Right, and then so now, like, because we're at the end of the array and all of these are false, then that means that we know that, well, you know, we've searched the entire array, we've not found it, right? Therefore, of course, 5 doesn't exist in the array, right? So here we can then just output false, right? Or we can return false. However, yeah, let's just undo some of these. Let's say, for example, we're searching for 8. Well, if we're searching for 8, and yeah, let's actually just use blue. Again, I mean, we're just going to do the same. So you say, well, is 4 equal to 8? All right, that's no. Is 7 equal to 8? Again, of course, just no. All right, but then here, well, we say 8, right? So is 8 equal to 8? Well, of course, that's true. So as soon as we find the match, right, then we're just going to return. And I mean here, well, of course, right, we're going to return true, right, like this. So what this actually means is that, well, we don't actually have to check the entire array because, right, when we return, well, then it's just going to leave the function, and yeah, it's actually not going to check 2. Likewise, it's also not going to check 3. So, I mean, this can actually be quite fast, you know, if we find, yeah, I guess if we find, you know, the thing we're searching for, like near the beginning. Right now, if people are in A2, you know, just think about this. Yeah, think about the time complexity. All right, so you should remember this is going to be O, well, yeah, say big O of n. And what this means is that, well, in order to find the element, right, then the worst case is we have to search every single item. So, of course, I mean, well, here we've got 5. So potentially the worst case is that, well, yeah, the worst case is that we have to search 5 elements. Right now, of course, you know, if we're searching like 5 million, right, or if the array has 5 million elements, right, well, then we would have to search 5 million. So, I mean, linear search, you know, it's not going to be fast, but for small arrays, you know, it's simple. And yeah, I guess, you know, because it's simple, right, that's what they kind of teach us for Cambridge. Yeah, although, right, if anyone is in A2, then of course you should also know binary search as well, which I guess we can look at in a future video. Right, okay, so now that you hopefully understand linear search, if you didn't before, right, let's just look at how we can do this. So I'm just going to go up here, okay, yeah. Right, so what we want to do then, let's actually create a function. And I mean, the reason this should be a function is because we're going to return true, right, well, either true or false. So true if we find the element, or false if we don't find it. So here then the name, well, I'm just going to call it linear search. Right, then the parameters, well, one parameter, if you think, yeah, it has to take the array. So yeah, it takes the data that we're searching. So I'm just going to call that like ARR. And let's say this is going to be an array, right, and then we just need the type. And again, like I think, like I mentioned in a previous video, now when we declare an array, we need to specify the dimensions. Okay, so the starting index and the ending index. However, you know, when we're using an array as a parameter, right, or also if we're using it here, if we're using it here as a return value, right, then we actually don't have to specify the dimensions. Because I mean, we want this linear search to work for, well, you know, any any integer array, or yeah, any dimension of sort of integer array, right? Because we wouldn't want to say something like this. Let's say like 1 to 10. You know, because, well, this would mean, well, it's only going to work for integer arrays, you know, with these dimensions. Like, of course, you know, then yeah, like that, you know, then if we have this, well, right, this is not going to work, right, because here we've got, you know, an array of 10. Here we've got an array like size 11. Yeah, I mean, so that's why here we just don't put the dimensions, right? Because again, it should be flexible. It should work for any size array. Yeah, like so any dimension integer array. Right, so well, again, right, one thing is going to take the parameter, but then if you think it's also going to take another parameter, yeah, oh, okay, sorry, yeah, so one parameter is going to be the array that we're searching, right, but then it's also going to take another parameter. So just have a little think about what that's going to be. Okay, so hopefully you realize that this other parameter, well, this is the actual data that we're searching for. So I'm just going to call this like maybe toFind, right, and then that's going to be an integer. So this will actually be the data that we're trying to find. And then if we think about the return type, well, again, it should be true or false. So this will just be a Boolean. Right, and then, well, I'm just going to end the function here, right, just so I don't forget. Then in order to do this, well, again, we just want to loop through the array, and then, you know, check element by element. So, well, let's just have 4, we can go n. Again, we're going to start at 1, and then, oops. Okay, that's kind of annoying. Right, and then if you think again, well, like, we're not going to hard code this 10, right? We just want to use this length. Now here, well, because this is a parameter, right, we're actually going to use, you know, this parameter. Yeah, not this scores, right? It's going to be the parameter. So yeah, we're just going to go length, and that's going to be of, right, this, yeah, array parameter. Again, I'm just going to do next n, right, just so I don't forget. And then if you remember in our example, we just want to check if the current element is equal to the element we're trying to find. So for that, we can just use an if statement. And to get the current element, well, we just go like this, right? So ARR and then index n, because, well, index n is the current index, right? The current position. And then we just check if that is equal to the element. The element that we're trying to find. And then, well, if it is, right, then if you remember, we can just return. So here we just return true, right? And then let's just go end if. Now, this will actually work for if they find it. However, let's think about if they don't find it. So if the element doesn't exist in the array. Now, for that we said, well, we have to check every single element. So if we think, well, when we get outside of the for loop, right, this is when it would have checked every single element. Because, you know, if we say, well, this length is 5, right, of course, so it's going to go, you know, 1, 2, 3, 4, 5. And then once it's checked those 5, right, if it gets kind of outside here, right, then this means, well, yeah, this means it's kind of searched the whole array. It's not returned true, okay, because it's not found the element, right, therefore it means it must be false. Yeah, I'm not sure if that, you know, description was good or not. But yeah, I mean, basically here then, if it gets to this point, well, this means it's not found it. Alright, and what I'm actually going to do, I'm just going to have an output here. So let's say, I don't know, yes, let's say searching for, yeah, okay, well, let's call it, or checking maybe. So let's go checking, alright, and then we can just go and then let's go, I mean, well, basically we'll just output this. Alright, so let's go ARRN. Right, then let's go equals, and let's go toFind. Yeah, okay, so I think that's fine. So basically what's going to happen then is, well, it's going to output this checking, right, and then, you know, if we find it, well, then it's not going to check anymore, right, because, well, I mean, it would have returned, basically. So if we just try and run this, and yeah, I mean, okay, I'm actually not going to use rand because, you know, that can make it a little bit sort of harder to see. So let's just say this is n, for example. So the array is literally going to be, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, 10. Right, so yeah, and then, right, what I'm going to do, so just don't forget to call it, then let's go output, and we'll say linear search, right, the array we're searching is scores, and then the element we're trying to find, well, that's going to be this user input. Alright, so I think this should work. So remember, right, the numbers 1 to 10 are going to exist. So let's just search for 4. Right, so if we think this should say, well, checking 1, right, then it'll be checking 2, checking 3, checking 4. And then, yeah, after it's checked 4, well, then it would have returned true, right? So, yeah, then it won't need to check 5, 6, 7, 8, 9, 10. And yeah, okay, so here we can see this. Right, and I mean, let's try, for example, 11. And then, yeah, we see, so 11, well, it's going to check all of them, right? But, of course, none of them are true, right? So that means it's never going to return true here. So, yeah, then it's going to get to the end of the for loop. And because it's reached the end of the for loop, right, then it's just going to return false. So, I mean, hopefully that makes sense. Now, I know for some people, you know, they understand this pretty quickly. Yeah, however, some people find it, you know, a little bit more difficult. So if you're still struggling with this, then I would say, you know, probably delete all of this, right, and then see if you can actually do it yourself. So yeah, you know, just think, right, first we need to loop through all the elements, then we just check if the current element is equal to the thing we're trying to find, right, and then if it is equal, we return true, right, you know, else, well, we just have to return false outside of the for loop. But yeah, I mean, hopefully that's okay. Alright, so yeah, we've spent quite a long time on that. So right now, let's just move on to this count occurrences. And I'm actually just going to kind of undo this, right, because it's going to be pretty similar. So if we want to count the occurrences, and for example, right, let's go, yeah, so this one can actually be rand. Right, hang on. Yeah, I was trying to go back, but yeah, I think I won't really be able to. So right here then, yeah, or okay, to be honest, right, I'm just going to do it just so we can actually see the data, because yeah, that's going to be easier to test. And again, right, remember, this is not really the way Cambridge likes us to do it. However, you know, well, since it's just for testing, right, since it's going to be easier, then yeah, let's just do it this way. So let's say we've got 8, maybe 4, 3, 6. Right, so how many is that? That is going to be, okay, 9. And then let's also go for... yeah, okay. Alright, so if... yeah, I mean, alright, let's go for another 8. Right, so let's actually change this. Let's call it maybe count. Yeah, I always mistype that. Right, let's go for count occurrences. And I think I'm also going to mistype that. Yeah, I'm not really sure how to spell occurrences. So here then, like, let's say we want to count the occurrences of 8. Well, if we think, right, I mean, well, it's actually going to highlight it. Yeah, it's going to highlight it for us here. Right, but we can see there's just going to be 3. So yeah, if we go count occurrences 8, right, that should return 3. So again, if we think, well, we also need this array, right, and then, well, we also need the thing we're trying to find. So I'm just going to rename this. And in fact, you know, one trick we can use is if we just right click on this, let's go change occurrences, right, and then let's go count, yeah, okay, count occurrences like this. And that, well, that's just going to rename it everywhere it finds, you know, that particular string. Alright, okay, so yeah, right, that's going to be fine. And then, yeah, I'm just going to zoom out a little bit, just to keep it all on one line. Right, so here what we actually want then, because well, here we're just counting, right, or totaling. So we're actually going to want to declare a count variable. So yeah, let's just say count, this can be integer. And then here, let's just go count and assign it 0. So in this case, yeah, I'm probably just going to comment this. Right, in this case, we don't want to return true, because if we think here, well, okay, so, you know, we're checking is 8 equal to 8, but if we just directly return here, well, you know, this is only going to return 1. Alright, but of course, you know, well, we can see later in the array, you know, there's going to be more. So, I mean, let's just think, well, this is actually going to return an integer, not a boolean. Alright, and then what we actually want to do, well, we just want to increment count. So we'll just go count, and then let's go count plus 1. Alright, so we're just incrementing how many counts there are. And then yeah, at the end, well, we don't want to return false, right? We just want to return, and then this will be the count. And yeah, I'm probably just going to delete this line. Right, so in this case, well, again, right, if, yeah, I'm still, well, let's say if you're familiar with like big N notation, big O notation, yeah, if you're in A2, for example, then this one is actually going to be O of N, right? Because, well, this time we always need to loop through, you know, N elements. So if the array has 10 elements, right, you know, then we need to loop through 10 elements. Whereas, for example, linear search, well, if we're searching for, you know, element 3, well, of course, you know, we find it here, you know, after the third position, so we don't have to search the rest. Right, but yeah, I think let's just run that because that should work. So let's say 8, and this should return 3. And yeah, okay, we see 3. Now let's try, for example, 7. Right, so 7 should be 0 because, well, yeah, it doesn't exist. And yeah, so we see here 7 is just 0. Alright, so that seems okay. Now let's say we also want to find the index position. And I mean here, so we could do it where we just find the first index position. Alright, so yeah, well, I'll give you maybe, you know, 10 seconds just to think how we can do that. So we want to find the first index position, right, of that element. Okay, so let's say again, well, I mean, we're just going to keep it the same. All right, we're also using toFind. Yeah, we're also going to return an integer. So, I mean, really, well, you know, these count occurrences find index position. I mean, they're just a variation of linear search, right? Yeah, basically it's the same code. And then, I mean, here we actually don't need this count. So, yeah, let's just maybe delete those. All right, and then what we can actually do here, well, let's just go return. And then here we just want to return n. Right, because let's say, for example, we're searching for, well, it's going to, right, okay, index 1, no, right, then it gets to index 2. So, right, index 2, well, this is what we want to return. Right, so yeah, we're going to return n, which would be 2, right, because, well, that's position 2 or index 2. And then I guess, right, let's say if it doesn't exist, well, let's just return -1. Okay, so -1 can kind of symbolize that the element doesn't exist in the array. And let's call it maybe find, let's call it find index position, or yeah, well, I think find index is okay. All right, and let's just run that again. So let's try 4. This should return 2, and yeah, okay, we see 2. Let's try, for example, 7 again, and yeah, okay, so 7 is -1. All right, because well, yeah, it doesn't exist in the array. I mean, right, let's actually extend this. So let's say we not only want to find the first index position, right, but we want to find every index position. And in fact, I mean, let's just output them, because in pseudocode, you know, we don't have sort of dynamically sized arrays. Because, for example, let's say 8. Well, if we wanted to return an array, you know, with like 3 indexes, well, right, then we would need an array of size 3. Whereas let's say, for example, 1, well, there's only 1, or yeah, there's kind of, you know, 1, 1. So because there's only 1, right, then that would be an array of size 1. And yeah, you know, we don't really have a way to sort of resize arrays in pseudocode, right, at least, well, not easily anyway. So, I mean, yeah, let's just make this a procedure, and then we'll say that we can just output. Right, so let's go procedure. I mean, right, let's call it find, indexes, or I think maybe indices. Yeah, that should be fine. Right, so procedure, if you remember, well, this won't return anything, so we can just delete that. Right, and then let's also just make this end procedure. Yeah, then we can also delete this return. Right, and then here, well, let's just go output. Yeah, then this, well, let's say maybe found at, and then, yeah, we'll just go like this. So, for example, if we say 8, well, this should say found at 1, then what is this, found at 6, and then found at 10. So, yeah, let's just try this and hope it works. So, right, 8, yeah, okay, found at 1, 6, 10, and, right, why is it giving this error? Right, and yeah, now that we changed this to indices, then right, we also just have to remove this output, because well here this is not going to return anything. So yeah, well, I mean, yeah, this is why I got this error message just running it a few minutes ago. So if we just say this is going to be call, so if we have a procedure in pseudocode, right, we have to use this call keyword, yeah, then just the procedure name. All right, and then yeah, now it should just work, and I'm just going to delete that. Right, so here let's go 8, and yeah, okay, we see found at well, index 1, index 6, index 10, right, no errors. And again, I mean, well, let's try like 15, and yeah, I guess 15, right, it just doesn't exist. Now, if we think, how can we get it to output an error message where it says, you know, 15 wasn't found, or yeah, didn't find 15 or something. So again, I'll give you, you know, maybe 10 seconds to have a think, right, pause the video. Right, so I mean, well, let's say the easiest way to do this, we're just going to have we're just going to declare, and let's say found, right, and then this can be Boolean. And then what we'll do is, well, if we find it, then let's say, yeah, let's say this found can become true, right? Now, I mean, actually, I think by default, Booleans should be false. Although, yeah, I mean, let's just, yeah, I mean, let's kind of be more explicit, I guess, right? Because, well, yeah, I mean, in the exams, they would want you to kind of, you know, give default values to things, right? So we'll say, well, found is false. Now, of course, if it goes through the whole array and, you know, it never finds where this is true, well, then that means found would never be updated to true, right? So that then what we can just do is, let's say, right, if found equals false, right, then let's just get output, and we will say, yeah, to find, right, and then just concatenate, maybe, yeah, doesn't exist in the array. Yeah, then let's go end if like this, and let's try again. So let's try 8. Yeah, so we see, right, that doesn't give us the error message, that's fine. Let's try 15, and okay, so yeah, 15 doesn't exist in the array. Alright, so now then if we look at this, right, so min, max, mean, and sum. Now basically we can do all of these together. So I'm actually just going to delete all of this, right, because, well, we don't need it now. And let's actually just use the same data, right, and then we can also delete this. So, right, okay, and let's also declare, for example, the min, max. Right, let's go min, max, and yeah, let's call it sum. And then, yeah, okay, so our mean, we don't really have to. Right, okay, so this is going to be integer, and I suppose, I mean, yeah, we could declare the mean if we want, right, but if we think the mean, this is actually going to be a real, because of course, you know, when we're dividing, while dividing, we could get a decimal answer like this. Right, now, a mistake that I see some people make is, I mean, well, yeah, probably you can figure out the logic, right? So the logic is that, well, we want to start on the first element, and then we just check. So for example, the minimum, we just check, well, you know, is the current minimum, or sorry, yeah, let's say, is the current element less than the current minimum, right? And then if it is, well then, yeah, then what we're going to do is we're going to set the current element to be the new minimum. All right. So I mean, what I see some people doing is, for example, they will say min, and then, you know, they'll just give it some value like this. So just give it some starting value. But the problem with this is, well, I mean, what if, you know, what if all of the data was actually bigger than this? For example, if you had data for like I don't know, the mass of different planets, and in that case, you know, yeah, like, well, even the smallest planet is going to be bigger than this. So you know, yeah, this is just not going to work. Right. Likewise, for example, max. Sometimes I'll see max going 0 like this. But again, you have the same situation. Like, what if? I mean, yeah, I'm just going to sort of do this quickly. You know, what if our data was like this? You know, -3, -4, yeah, etc. So what if all of our values were negative? Right. Then at the end, it's going to say that our maximum was 0. But if we look at our actual data, well, yeah, our data, you know, the real maximum actually wouldn't be 0. or I guess, yeah, the maximum would be, you know, less than 0. So what we actually want to do is, well, we want to set the minimum and maximum, right, to be equal to this first element. All right, and then, yeah, we can also set the sum to be equal to the first element as well. Yeah, although I guess we don't really have to do that. All right, so let's say here then, and yeah, let's just put this above. Because again, you know, the code is going to execute top to bottom, right? So yeah, we need to assign this array first, right? And then we can actually access. So this is going to be scores and then index 1. Right, this here is going to be scores index 1. Now, I mean, we could also go like this. We could say sum is also scores index 1. Right, and then in this case, we would actually only have to start looping from index 2. Right, however, I'm actually not going to do this. Yeah, I'm just going to start from 1. Right, so let's say for n, again, that's going to be 1. And then again, let's just go to the length of the array. Right, so to length of scores. And yeah, again, let's just close it first. So, I mean, what we can do, well, we just think, so scores n, right, or scores index n, this will be the current position. So let's just do the sum, right, because this is quite easy. So the sum, well, it's just going to add the current position, you know, then it goes to the next one, right, then it adds, you know, sort of, well, the next current position, right, then the next current position. So basically it's going to be sum, right, this is then going to be sum, so we're just kind of, well, yeah, we're adding it to the previous sum, basically. Right, then we just go scores, and this will just be n. So if we just walk through this, well, okay, yeah, sorry, this sum will start at 0. Right, so here we're going to have, well, you know, when n is 1, right, so we have 0, and then this here, well, scores 1 is going to be 8. Right, so basically that means that, you know, well, we're going to assign 8, right, into this sum, so sum will become 8. Right, you know, then of course we're going to go to the next loop, right, so n is going to be 2. So then what we've got, right, so, you know, that's going to be this 4, right, so scores n 2, well, yeah, scores index 2 is going to be 4. So on the next loop, well, then we've got 8 and then plus 4. All right, so this is going to be 12. So then we're going to assign 12 into sum. And then, you know, again, just following on, well, then we're going to go 3. So here, I guess we see, well, index 3 is 3. So then we've got, well, 12, right, plus 3. So, of course, that's going to be 15, right, and then 15 is going to be assigned into this sum. Of course, well, then it's going to go, you know, 21, 22, 30, 39, 41. Yeah, 44 and 52, I think. So, right, I mean, if we just try that, so that one should actually be working. And yeah, let's just go output sum. Right, and let's go sum like this. And yeah, I think I've not missed anything. And yeah, okay. Alright, so, I mean, we see sum. Hopefully this is actually quite easy. Now, if you think, right, once we've got the sum, well, we can then also really easily calculate the mean, because, and again, right, I'm just going to assign it like this, although we actually wouldn't have to. The mean, well, that's just going to be the sum divided by the number of items. So let's just say that's going to be length of scores. Right, and then here, let's go output. And yeah, okay, so like this. And I mean, this should say, what, sort of 5.2, I guess. Yeah, okay, so 5.2. Right, now, if we try these min and max, because these are going to be a little bit more difficult, although, yeah, hopefully not too hard. So what we can actually say then, let's say if, and this will be scores. So, I mean, this is the current, sort of the current position, right, you know, the current value. So if the current value is less, so let's say less than the minimum, right, then we're going to go and we're going to say the minimum, and right, we're going to assign that to be the current value. So if we think, well, actually the first one is just going to be 8, right, so yeah, the minimum is going to be 8, and then this scores will also be 8. So here we check, well, is 8 less than 8? All right, no. So yeah, let's end if. Right, so because this is false, well, then it's just not going to do anything. Right, so again, then we go to the next loop. So here it's going to be 4. So now we check, well, is 4 less than the minimum? And right, remember the minimum currently is 8. So in this case, this will be true. So then what we're doing is we're going to assign 4 to be the new minimum. right? So yeah, now 4 is the minimum. Of course, right, then we go to the next one where we say, right, is 3 less than, well, yeah, is 3 less than 4, right, because 4 is this minimum. Of course, this is going to be true, right, so now 3 is going to be assigned into this minimum. I mean, this one, right, so, well, 6 less than 3, right, no, so it's not going to do anything. Of course, 1, well, yeah, 1 is going to be true, right, so then 1 will be assigned to the minimum. And then I guess, yeah, these are all going to be false. Alright, so let's just output that just to check if it works. So let's say min and min like this, and it should say 1. Yeah, okay, that says 1. And then, I mean, if you think, right, we can actually use the same logic just for the max. So here, let's say max, and then, well, we just want to change this. So yeah, is the current score bigger than the maximum, right, or the current maximum? And then if it is, well, we'll just, yeah, set this current, sort of current value to be the new maximum. And right, let's copy this, and yeah, let's try again. Right, and then yeah, this should work. And yeah, the maximum is 9. Yeah, okay, so this seems fine. Right, now let's actually show you what would happen if we didn't have this. So if we think, for example, well, minimum is going to be 0, right, maximum is going to be 0, okay, because yeah, we just use these default values. Now, what is it going to say here for the minimum, right, and what is it going to say for the maximum? So, if we don't assign it to be the first element here. Right, so if we actually think about this, well, the minimum is actually going to say 0, right, and let's just run this. Yeah, and the reason it says 0 is because, well, of course, well, the starting value is 0, and, all of these, right, all of these are going to be bigger than 0. So we're actually never going to update the minimum. Let's say, for example, we do this, like minimum, just give it some huge value, right? And then let's say maximum can be 0. I mean, this should actually work in this case, yeah. But again, for example, like if all of these were negative, so I mean, well, I'll let you think what's going to happen now if all of these are negative, right? Then what's it going to say for the minimum, and what is it going to say for the maximum? Right, so if we think, well, the minimum then, it should be this -9, because yeah, this will be the smallest, this is going to update properly. But then if we think the maximum, well, the maximum is always going to be 0, because like all of these will be smaller than 0. And then yeah, so we can see that's like this. Alright, so basically, that's why we don't want to give it some starting value like this. Now, of course, I mean, we could just have it like this. But the problem is, again, what if the data is actually sort of like bigger than this minimum? Or yeah, what if the data is, smaller than this maximum? Yeah, so, yeah, obviously we can't do this because, well, we just don't know what the data is. Alright, so again, yeah, that's why we always just want to assign it to be the first one. Now, we could also start from 2 like this. And the only thing we have to be careful of is, well, if we start at 2, right, then the sum is not going to include this one. And in fact, yeah, I mean, let's just do it like this quickly. Right, so if we do this, well, you'll notice, so I guess the sum should actually be 44 in this case, right? Because it's not gonna count this 8, right? That's because we're starting at 2. Yeah. So what we can then do in this case is if we go sum and then again just assign that scores 1, right? Then it means we can actually start at 2 here like this. Yeah, and okay, this works. All right. However, like don't kind of mix them, right? So don't have sum is scores 1, and also start at 1, right? Because then you're actually going to be adding this 8 twice. So I guess, yeah, this will now be 60. Yeah. So again, I mean, that's the only thing to be careful of, right? If I guess if you're starting at 1, well then you wouldn't set this kind of sum to be the first element, right? But if you're starting at 2, right, well then, yeah, if you're starting at 2, well then you would have to set this sum to be the first element. Alright, so yeah, I think for simple arrays that's mostly done. I mean, the only thing we have now really is just sorting. Alright, and yeah, then we can just have some practice looking at some kind of real life examples, yeah, or exam questions. Alright, so let me just try to explain bubble sort quickly for people that are not familiar with how it works. Now, there are also a lot of videos online explaining this, you know, a lot of kind of animations and things. So if my description doesn't make sense, right, then you're also welcome, you know, go and check out those, right? But before we start programming this, make sure you actually know how this works, right? Make sure you've got a good understanding. So, right, let me just write then. Okay, here we go. Yeah, let's just write bubble sort. And again, yeah, my handwriting with this graphics tablet is probably not the best. Right, and well, let's start with an array. And I mean, yeah, maybe let's just go 7, right, let's say 4, or let's say 3. Yeah, maybe we can have 6, and let's try 2. Alright, so what we want to do, well, we want to sort this in ascending order. So ascending means, well, smallest to biggest. So if we think about this, well, basically 2 should be, you know, sort of element 1, right? Well, it's going to be, yeah, 2, 3, 4, 6, 7. Yeah, that's how we want to sort it. So with bubble sort, basically, well, we're going to have 2 loops. So, I mean, the first loop is well, yeah, the first loop we can think kind of as sort of like looping down the rows. And then, yeah, inside that, you can think of this kind of as like, I mean, kind of looping through the columns, right? Or just, yeah, let's say kind of comparing the elements, basically. Alright, so how we start this then, we start with the first element, and then we check, is this bigger than the second element, or yeah, is this bigger than the next element? So here we check, well, 7 is bigger than 4, so because that's true, then we swap them. Alright, so 4 will become this first element, then 7 will become the second element. Right, now we just do the same, so we say, well, is 7 bigger than 3? And in this case, right, that's also true. So yeah, then we're just going to swap them again. Alright, and yeah, let me just erase that, undo. So yeah, now this is going to become 3. Right, this one becomes 7. And yeah, possibly, you know, you can spot the pattern, right? We just do the same. So we say, well, is 7 bigger than 6? Alright, yes. So again, let me just undo that. Alright, so this becomes 6 and this becomes 7. Of course, well then 7 bigger than 2, alright, yes. So this becomes 2. Yeah, there we go. Right, and then yeah, this final one becomes 7. So right here we've actually done the first pass. And I mean, let's just talk about the optimization quickly. Right, so one thing you might notice is that right after the first pass, the biggest element is always going to be in this kind of last position. So yeah, let's just get another color. Right, so we see, right, 7 is this, oops. Okay, yeah, 7 is this biggest element. Right, and then, well, we'll actually see that on the next pass, yeah, I mean, so, well, the next pass, you know, 6 is going to be the second biggest element. So it's going to, you know, it's going to come in this kind of second rightmost position. So there's actually an optimization that we can do where when we check it next time, well, we don't have to compare, you know, all 5 items like this or all 5 elements. You know, we can actually kind of just ignore this 7, right? So we're like, now we only need to check these next 4. Yeah, so let's just do that quickly. And I think I was using this orange. Or in fact, well, let's just use a different color just to make it easier to see. Right, so again, well, is 4 bigger than 3? Well, yes. Right, so here then this is going to become 3, this is going to become 4. Right, now here, so is 4 bigger than 6? No. So because this is false, right, then they'll just stay there. Alright, they won't change. Right, but then here, well, then we get 6 and 2. Well, 6 is bigger than 2. Alright, so yeah, we're just going to swap those. Alright, and again, I mean, now we can see, well, right, these ones, we don't have to check these, 6 and 7. Right, so yeah, now we're only checking these 3. And yeah, let's kind of make it artistic, I guess. Right, so well, is 3 bigger than 4? Yeah, no, so they just stay there. Right, and yeah, let's just write this. Alright, and well, then we check, is 4 bigger than 2? Well, yeah, that's true, right, so then we're just going to swap those. Right, okay, 6, 7. Yeah, and I guess this time we can say, right, all of these we don't need to check. Right, so I'm here right on the final go, so we just check, well, yeah, is 3 bigger than 2? And yeah, let's just get a different colour. Alright, so here we're just going to swap them. Alright, and then well, these are going to be already sorted. In fact, no, that's 6 and 7. Yeah, okay. Alright, and then, yeah, I mean, I guess here we can just kind of stop, to be honest. Alright, so, I mean, again, you know, the thing to note is that, well, here, right, we can just compare one less each time. So the first time we have to compare 5. I mean, well, 5 elements, but basically just 4 comparisons, right? Because we're, you know, 1 comparison, 2 comparisons, right? 3 comparisons, and 4 comparisons. Right, and then of course, well, the next time only 3 comparisons, 2 comparisons, right? Then 1 comparison, and then yeah, I guess well now right there's 0 comparisons, so that means it's sorted. So right, that's actually one of the optimizations. Okay, just kind of reducing the number of comparisons we do each time. Alright, now there's also another optimization where let's just maybe undo all of this. Alright, there we go. So let's say we had, I mean, let's say we just got the array, you know, 1, 2, 3, 4, 5. We can actually have a Boolean. So, I mean, yeah, let's just call it B, right, Boolean. And what we'll say is this will represent if it's sorted or not. Or yeah, we can call it did swap. So let's actually say this is going to be false. Or okay, again, let's just change the logic. So rather than checking is false, right, let's check is true. So here, let's just call this sorted. And then right, let's say sorted is going to be true. So right, we're going to assume that the array is sorted, right, by default. So what we're going to do then, well, we check, right, okay, so yeah, 1, you know, right, is 1 bigger than 2? No. Right, 2 bigger than 3? No, no, no. So here, I mean, we can check each element, right, and we'll actually find this is sorted. I mean, yeah, let's actually just change this a little bit. Let's say maybe there's a 7 here. So if there's a 7 here, well then we check, right, is 7 bigger than 4? Well, in this case, right, this is, yeah, I mean, this is bigger than 4. So if we find a situation where we have to swap them, right, then, yeah, then we're just going to change this. Right, so then we say sorted is going to be false. And then, I mean, yeah, so basically what we can do is that, well, if we go through the entire array and sorted is still true, well, this means we didn't need to swap any. So because we didn't need to swap any, right, then that means it must be sorted, right? So, you know, we wouldn't then have to kind of go through again, you know, kind of the next row, the next row, the next row, and, you know, do the comparisons again. Right, so yeah, I mean, we'll look at how to make the basic bubble sort algorithm, right, and then also how to do bubble sort with these 2 optimizations. Alright, so you might have noticed I've actually just simplified this array a little bit. Okay, we've only got 5 elements just to make it easier to see. So in order to actually do this, well, let's actually make a procedure. Now, there are a few different ways to do that. You know, we could do it just with no module, right, so no function, no procedure. You know, just kind of, well, just directly do it here in, you know, in the global scope. Right, however, I think, yeah, well, I mean, let's say, you know, it's probably better to use, you know, either a function or procedure, right, because, well, then we can just reuse it. And I mean, there's kind of like 3 ways we can do it, right? Either we can use the global variable, so that's going to mean directly updating the scores. Yeah, or I guess we could use by reference, right? You know, this could also be used with the procedure. So yeah, I mean, well, this would also be, you know, directly updating scores. But here, you know, we would pass scores, you know, as a parameter, right? Kind of passing it by reference. And then, yeah, sort of by value, well, this could be if we're using a function, right? Then we're going to create a copy of the array, and then we would return a copy of the new array. Yeah, or well, you know, we would return the copied array, but, you know, the copied array would have been sorted. All right, but I think, well, let's go with the sort of probably simplest one, right? Let's go with global. So yeah, we're just going to use this scores identifier, okay, the scores array directly. Right, so here then, yeah, let's just call this bubble sort. Right here we actually don't need any parameters because again we're just going to use the global array, right, and then we'll just go end procedure. Now, I mean, usually, you know, in most languages we could do this using a for statement. However, I think for procedures, I mean, they don't really like using, or yeah, well actually I'm not sure, right? Maybe this is supported, maybe it's not. Just using a return statement to kind of exit out of a procedure. Right, I mean, if you're familiar with other languages, right, there's also, you know, for example, no break statement, which means kind of exit a for loop. So, you know, if we're talking about doing those optimizations, well then, yeah, I mean, well then we're not going to be able to do that using for loops basically, because, you know, for example, a for loop is always going to loop 5 times. You know, for example, if we're looping like 5 rows, okay, because yeah, we're, you know, kind of, you know, we're going to sort the first row, right, then it's going to go to the next row, the next row, the next row. So yeah, I guess maybe a better way we can do this is using a while, or yeah, a while loop. Right, so let's actually create some parameters. Right, let's declare, and this can be maybe the column, right, or yeah, the index. Yeah, I mean, yeah, okay, I mean, let's call it index, that's fine. Right, let's say this is integer, and we're going to start while the index is going to be 1. Right, and then I guess we're also going to need a flag, right, so the flag can just represent true or false, and this will be if we had to perform a swap. So let's go here and we'll say maybe did swap, and right, this did swap can be a boolean, so true or false. And what we then want to do is, while we say while, so we want to say while did swap equals true. Yeah, because right, if did swap is true, then this means, well, yeah, that you know, it was unsorted, right, because they had to switch, or they had to swap some elements. Right, so what we then want to do is, well, let's say did swap, and we'll just assign this to be true first, right, because, well, otherwise if this is false, it's never going to try this while loop, or yeah, it's never going to execute the code inside this while loop. And yeah, let's go end while like this. Alright, so yeah, let's just think then. So then what we can do is, well, here we can have a for loop inside this. Alright, and we probably, yeah, let's have maybe another integer, let's call it like end position. So the end position in terms of, you know, the last element we need to check. Yeah, and I think what we'll do is, well, we'll say the end position will be 4 in this case, because what we're doing is, well, we're you know, we're comparing 4, right, with kind of, you know, n plus 1 or 4 plus 1. Now, if we set the end position to be 5, well, then it will try to compare 5 with 6. But, you know, of course we see here, well, there's no element 6. Right, so yeah, this one can just be the length minus 1. Right, so let's say that the end position, right, okay, hopefully that resets it. Okay, so end position, and that is going to be length of, yeah, so length of scores minus 1. Right, and then what we want to do then, let's loop. So yeah, I mean, actually here we have index already. So right, I'm just going to delete that index, right, I think we don't need it. So let's say for index, and this can be 1, right, and then let's go 2, and then this will be the end position. Right, and then let's just go next n. Sorry, okay, next index. Alright, so what this is going to do, well, it's going to start here at, you know, sort of index 1. Right, then of course we're index 2, index 3, index 4. And then, yeah, well, the end position, right, well, the end index is going to be this index 4. So yeah, it's not going to go past that. And then, I mean, let's just do this now, and then we can do the stuff inside the loop later, right? But we need to think, well, once we've sort of looped through, you know, every index, then we just say, well, the end position is going to be end position minus 1, because again, we should say, well, this 8, right, after the first pass, then this 8 should be in this, you know, kind of rightmost position. Yeah, after the second pass, well, actually, yeah, these two are going to be sorted. right, after the third pass, what then it's going to be, I guess, yeah, 4, so it's going to be, well, 4, 6, 8, you know, after the third pass. So yeah, each time we just have to check, right, one less, which is what we just saw. Right, and then, so here, this is where we just want to compare them. So what we want to do, well, we want to say if, and this will be scores. Right, then this is going to be the index. And we want to say, right, if this is bigger than the scores and then index plus 1. So for example, in this case here, right, so if 8 is bigger than, well, index plus 1, which is 4, right, so in this case, well, this is true, okay, then we want to swap them. Right, okay, so yeah, then, well, let's go then, and let's go end if. Right, now, this swapping, this is where I think a lot of people get confused, because what they might think we can do is, well, they might think we can go, let's say, scores and then index, and that's going to be scores and index plus 1, and then let's say scores, right, this is going to be index plus 1, and then yeah, this is going to be scores, right, index. So, I mean, you know, this is kind of, well, yeah, I guess this is the kind of common sense logic, but if you actually think about this, right, this won't quite work. Because, for example, what's going to happen? Well, this scores index plus 1, right, this will be this 4. So then we're going to put 4 in this index. So this index, right, this is, you know, position 1. So what that's going to do, well, now it's going to be 4, 4 like this. Right, and then, well, what we're going to check next, then we're going to check, you know, index, and we want that to go into index plus 1. So that's saying, you know, this one here should go into this position. But, okay, so 4, and then, well, 4 is just going to overwrite 4. Okay, so, I mean, well, it did copy, but the thing is, you know, it's just copying the same thing. So basically, you know, we lost this 8 by doing it like this. So in order to actually solve that, well, we just need a temporary variable. So let's go temp, right, this will be integer. Now let's say, for example, maybe we can put this 4 in the temp, then we can put the 8 in this 4 position, right, and then I guess we can put the temporary, right, back in this 8 position. Right, so let's think then, so yeah, okay, right, let's go like this. And you know, you can also do it the other way, where let's say the 8 goes into the temp, the 4 then goes into the 8, and then I guess, yeah, the temp then goes, you know, into the 4. Yeah, I mean, obviously, it, you know, doesn't matter which way you do it. Right, so we're saying, okay, so this 4 is going into the temporary. Right, then we want to say this 8 should go into the 4. So yeah, that's fine. Scores index, that's going to go into the index plus 1. Right, and then I guess the next one we said, that's going to be where the temporary then goes into this one. Or no, okay, sorry, yeah, the temporary goes into the scores index. Alright, so yeah, let me just check that. Right, so scores index plus 1, that's this one. Right, this is the temporary. Right, then the next one we say, well, scores index. So right, just yeah, the first one. That then goes into here, right, and then the final one, well, the final one is the temporary, yeah, which is going to be this 4, right, then, yeah, that 4 is then going to go into this index, which is, yeah, this 8 position, right, so I think that should work, and yeah, what we also want to do then, we just want to have this did swap. Now, what we can say is, let's say in here, well, we're going to set did swap to be true. Okay, sorry. All right, yeah, we're going to set did swap to be false. Right, so this is kind of assuming that it's sorted. And then what we'll actually do is, well, inside here, right, then let's just go did swap, and this will be true. Right, so, well, this means they had to swap, which is, you know, the array was unsorted. Right, and then if it's unsorted, well, you know, then you have to just loop through again, basically. Right, I mean, so I think that should work, yeah, if there's no mistakes. So let's just try and run it, and then, yeah, if there are mistakes, let's try and fix it. Right, so first I'm going to remember just to call it. So let's say call bubble sort, just to actually use this procedure. Right, then let's go for, and let's say n is going to be 1. Right, then we'll go to length. Again, this is to the length of scores. Right, so here we're just going to output the array, right, just to check if it's actually worked. And then yeah, this is going to be scores index n. So hopefully this should just print them in ascending order, right? So well, 1, 3, 4, 6, 8. So yeah, let's give it a go. And yeah, okay, so this actually works. Now you can see, you know, I mean, this is a little tricky, right? And I mean, I know some people, they do just remember it, and if you can remember it, that's good, right? Although do try to understand it as well. And you know, I think even me, you know, honestly, it's been probably, you know, 3 or 4 months since I've actually done this. So yeah, I mean, you did see I was also struggling to remember, you know, the exact logic. Because, you know, the thing is, right, you can actually modify this logic a bit. For example, this, you could make this kind of opposite. So rather than say did swap, I guess you know, you could call this is sorted. So then it's like, well, while is sorted equals false, right? Then you could put this, well, is sorted, and then assign it true. And then here you'd go, you know, is sorted, and then you would, yeah, I guess then you would, you know, assign this false. You know, of course, likewise this temp, right? You know, you could swap it the other way. But yeah, I mean, so obviously how you do it is up to you, right? But you just have to be consistent. And yeah, obviously, just kind of think about the logic, right? You know, try and go through it in your head, make sure it works. Right, so we've seen here then, well, you know, this is how we do it in ascending. But let's say, you know, maybe in an exam, they would ask, how can we sort it in descending? So we want to go from, you know, let's say biggest to smallest. Right, so again, I'll give you like 5 seconds just to think how we can change this to sort in descending order. Alright, so actually pretty simple, right? All we have to do is just change this. So rather than checking if the current position is bigger than the sort of next position and then swapping them, well, let's just change it. So let's make it smaller than. So let's say, for example, yeah, I guess this one, right? So right, if the current position is smaller than the next position, right, well, then we would swap them like this. So yeah, then that's going to be what, 8, 6, 4, 3, 1. Right, so just going in kind of descending order. Right, and then yeah, let's just run this. And then yeah, okay, so you see, right, so biggest to smallest. Alright, so I mean, yeah, that's obviously how we can just do bubble sort. Now, if we want to use, say, by reference, well, let's just look at how we can do this quickly. Right, so what I'm going to say ByRef. This will then take an array, and this array it should be the same type basically. So it's going to be array of integer. And then right, what I'm going to do, yeah, we've got a lot of them here. So let's say this is going to be array, right? This is going to be array. Yeah, let's just update all of these, right? Make sure I don't miss any of them. Right, and then yeah, that should also work, right? Just as long as I call scores like this. Now you may think, you know, what's the point of doing this? Because, well, here, you know, we can just directly update, or well, we can directly access scores, right? But I mean, that's only because this is a global variable. Like, let's say, for example, this scores, maybe this is it. I mean, I don't know, some function ABC. Let's say it just returns integer or something. Yeah, let's go, okay, end function, and then just return like 1, 2, 3. Now, in this case, okay, there we go. In this case, well, scores now is just going to be a local variable inside this function. So that means that, you know, bubble sort wouldn't have access to this scores, because for well, yeah, let's just copy that inside here. Right, okay. Yeah, okay, there we go. All right, so yeah, in this case, well, you know, this scores is just a local variable right inside this function. So only things inside this function will be able to actually access scores. All right, so, you know, we wouldn't be able to do bubble sort and then, for example, use scores here. Right, and I think, yeah, okay, so, you know, right, we don't even get any code suggestions. Because, well, the website has realized, you know, again, right, this scores is just, well, basically it's local scope. Yeah, just, you know, just in this function. right? So in that case, well, then we could pass it as a parameter, right? Which is what we're doing here. So we're calling bubble sort. We're using this scores, which again is this local variable, and because it's by reference, well, that means by reference, it's going to directly update this scores. It's going to directly update this scores array, right? So I mean, this should actually work, and yeah, let's just call it again. I mean, I'm just going to go output ABC, although this is a little bit pointless. I mean, basically, well, this ABC is just going to return. Okay, well, yeah, let's use it like this, right? Like, honestly, it would probably be better if this was a procedure, but yeah, I guess I've made it now as a function. Or, I mean, okay, let's make it return a string, and then maybe here we'll just go finished or something. Right, so, I mean, this should just do the same again. Okay, scores has not been declared. Okay, right, that's because I changed it and then didn't change it back. Alright, yeah, so you see, I mean, here, right, this also works. Again, most exams, they will just let you use the global variable. Some exams, they will, I mean, well, let's say for, A-level especially, right, for IG, just use the global variable, right, it's going to be more simple. Yeah, I don't think they would want you to use, kind of passing arrays by reference for IG, right, that's going to be too difficult. Yeah, because, well, I mean, also ByRef is not on the syllabus for IG, right, but, I mean, for A-level, they could ask this, and if you do need to directly update the array values, but passing it as a parameter, then you actually have to use this ByRef, right? Because, for example, let's say we try ByValue. Now again, right, ByValue, well, this will then, I mean, this will create a copy of the parameter. So this scores, right, it's going to create a copy of that scores for us, of that scores array. Right, we can then use, we can use the identifier like ARR in order to access that copy. But the problem is, right, anything we edit here, well, this is just going to be the copy. So for example, actually, let's just copy this, and right, let's go after this while loop. Right, and then let's just go output, and let's say maybe done bubble sort. Right, and again, so this one is going to be ARR. Okay, like this. Right, so here this should actually be sorted, but again, this is the copy that's sorted. And yeah, well, this scores is never going to be updated with the copy, basically, right? Because they're going to be different arrays, right? Different objects. So what this should do is, well, the first one should be sorted, right? But then when we output the actual scores array, well, this is not going to be sorted, right? It's still going to be this original. So we see, so this one here, right? This is inside, which is sorted. And yeah, this one here, we're outside, right? So it's unsorted. Now we could actually change this, so let's make it a function, and let's say it's going to return, and that's going to be an array of integer. And let's say, let's say here, let's just go return, and that will return array, and let's make this end function like this. And right then, what we need to do, let's say scores. Right, okay. So here then, what we're going to do, we're going to call bubble sort on scores. We're saying that bubble sort now is a function which returns an array of integer. So again, right, that's still going to create a copy because we're using ByValue, but basically the copy is going to be sorted, right? Then we're going to return that copy, and then the copy is then going to be assigned back into this scores. All right, so I mean, this should work, although this will actually be kind of slow, inefficient, because well, here we're creating a copy, then we're sorting the copy. So it takes more processing. Right, so unexpected token return, so 26. Okay, so right, this should be returns. Right, so again, the one in the let's say function header, when we're saying what data type that should be kind of returned from the function, well, then we say returns integer, returns string, right, returns array of integer. But when we actually return the sort of data inside the function, right, then we just use return. Right, so let's see if it works now. And yeah, okay, so if we look at this first one, then this is going to be the copy, right? So the copy has been sorted. Then we're going to return the copy. And then, yeah, I guess this copy is then, well, it's then going to be assigned to this scores. And then, yeah, this scores, well, this is then also sorted. Right, so, well, probably that's, confused a lot of people. And yeah, to be honest, I understand because it is a sort of confusing concept. So I would say if you're having sort of trouble with this, again, right, you can just go down here, and then you can look at these, right, ByVal, by reference, yeah, sort of simple and also arrays. However, if you're doing IG, then yeah, just ignore this, to be honest. Right, just always use the global variable if it's for arrays. Right, so let's see if we can actually use what we've learned then. So we're going to have one array which is going to contain names and one array which is going to contain scores. So this could be like a player, some kind of game, right, with usernames and player scores. And then, right, what we want to do, well, we're going to use bubble sort, I guess, to actually find the players with the highest score. Right, and then we also want to output the sort of, the usernames that scored the highest. Right, we also want linear search, so this is to find the player's score. So for example, I guess we can search by username and then we'll output that person's score. Right, and then we're also going to output all players with a score of, well, let's say above 5,000, for example. Right, so yeah, let me actually just undo some of this. Let's go back to just when we're using the global, kind of global arrays. Right, yeah, I'm not sure how far back I need to go. Right, okay, so I think that should be fine. Let's just check that that works. Yeah, okay, so I think that's fine. Right, so let's say here then, let's make these scores bigger. Let's say maybe like, yeah, I know, 7,000, maybe 8,000. Let's go maybe 3,000. 4,000 and maybe 9,000. Alright, and then let's also have players as well. So this can be their names. So let's go, yeah, maybe usernames. Right, and then if we think here this is going to be an array, let's also say 1 to 5, and this will be of string. And actually this time I'm just going to use the other syntax. So here we're just going to assign, 1 by 1. So I don't know, this one can be, yeah, like honestly, I'm just going to say, alright, let's say maybe like Alice 1 or something. Yeah, I'm really not very creative with, thinking of names and things. Right, let's say, for example, I know Bill 2, let's say Chloe 3, let's say Dave 4, and I don't know, maybe Ellie 5. Alright, and then yeah, let's also make sure just to update these username indexes. Right, so first then let's say we want to sort this. So I guess if we look at this, well, the winner is going to be Ellie, right? So it should say, sort of, well, position 1 Ellie and 9,000, right? So in this case, well, we have to sort the scores, but we also have to sort the usernames, right? So we have to sort them at the same time, or yes, simultaneously. So let's just say cool. And let's also, or in fact, actually, I think I've got this down below. Yeah, okay, I've got this here. Right, so what we also want to do then, here the length is fine because, well, they're both size 5, right? They've both got 5 elements. And I think the only thing we need to do, because, well, we're checking that. Yeah, okay, and hang on. Right, let's just. Okay, no, all right, let's make it like this. Because what we want the highest score to be position 1. Right, and yeah, so actually, this is fine. So all we need to do is just add the swap for the usernames in here, right? Because, we don't need to compare the usernames, because, yeah, well, the thing that we're comparing is the scores. Because, well, the scores is going to determine their position, basically. All right, so what we're going to do, let's create another temp, but let's call this maybe temp name or temp username. And then basically let's just copy this, but just change it for usernames. So this will then be temp name, right? This will then be, okay, usernames, right? Again, yes, scores, usernames. Right, then that should just be temp name. And yeah, so I think that should just work, right? And then when we output, let's just go, right, let's say we want the position, so let's say n, right? Then we'll just have the brackets like this. Then we can go, okay, so let's have the username, I guess. And then what we'll do is we'll just have these scores in brackets. Right, so hopefully this should say kind of, you know, LE5 and then 9000. Yeah, let's just run this. And yeah, okay, all right, so we see this works, right, quite nice. Right, now the next one, let's say we want to, right, we want a function to do linear search, so to find a player's score, yeah, I guess based on their username. So if we type in, you know, Alice1, right, it's going to return 7000. So in fact, actually, let me just collapse some of this, right, because yeah, it's getting quite big. Right, and yeah, maybe let's just, I mean, like, honestly, you know, it doesn't really matter where we declare this, right? And in fact, can I copy like this, maybe? Yeah, check that. Okay, yeah, so I'm just gonna, you know, declare this stuff at the bottom, right? And then let's actually use the code. Right, there we go. Yeah, okay. All right, so yeah, I'm just going to declare the functions and procedures, right? So the modules at the bottom. Right, let's go function. I mean, we could call this linear search. You know, we could also just call it get score. Right, and so this then is going to take in a username. So, I mean, well, let's call it like uname, right? Username. This is going to be a string, and then we're just going to return. Okay, and this is, you know, I say return, but again, right, the keyword is returns, right? So this function returns, and then, right, that's going to be an integer. Right, again, let's just end function, and what we can do, well, we just want to loop through, so for n, right, so n is going to be 1, and then this is to the length of, I mean, yeah, honestly, you know, we can use either. I mean, let's actually say usernames, right, because, well, usernames is the one we're searching. Right, let's go next n, and then again we just check, right, so if, yeah, okay. Alright, so, right, let's say if username's index n is equal to uname, right, then we're just going to return, and then here this is going to be scores at the same index. Because, for example, what we're saying is, well, you know, username 1 is going to be the same, or, you know, this is the same person as, you know, scores index 1. Likewise, you know, username index 4, right, that's going to be, well, you know, say Dave, yeah, their score is, you know, also index 4, right, but in the scores array. So, of course, the key thing here is that, I guess what you'd say, they have to be kind of synced, right, so yes, scores and usernames have to be synced, whereby, you know, the same index in, you know, in each array is going to correspond to the same person. Alright, but yeah, that should be fine. Then let's go end if like this. And then let's say here, let's just go return, and we'll just say -1. Yeah, I mean, or we could say 0, -1. Alright, so let's say -1, and this means, well, that person didn't exist. Right, so yeah, let's just see if this works. Let's go maybe output, and let's say, yeah, I know Dave 4's score. And right, let's go get score, and right, this is then going to be Dave 4. Yeah, and I think that should work. Right, and then let's try, I don't know, like, I mean, let's just say Fred. So I guess Fred 6. Right, and then yeah, of course, I mean, this one should just return. Yeah, okay, this one should return -1. Right, so let's try this. And yeah, okay, so Dave 4, 4000, right, Fred 6, -1. Alright, so just one more. Let's say we want to output all players with a score above 5000. And actually, we can make this a kind of variable. Alright, so make it a parameter. And then, yeah, you know, this like threshold can change. Right, so, yeah, let's make this a procedure. So let's say, I know, scored above. So just output players that scored above. Right, let's say maybe, yeah, let's say amount. This can be integer. Right, then we'll just go end procedure. And again, I'm just going to copy this, right, because it is just the same. Right, then we're going to say, okay, that's going to be scores. Right, yeah, okay. Right, so I mean, in here, then we just need to check, well, if scores index n, and I mean, let's say greater than or equal to, and then, yeah, that's going to be greater than or equal to the amount. Right, and then what do we want to do? Let's say we just want to output, yeah, again, let's say, okay, let's say we want to output the username and then scored and then the points. So here, let's go usernames n. Let's say scored. Right, then it's going to be the points. And then we will just say like and points. Right, and then I think, yeah, okay, so I think that should work. Right, so let's just try that. Again, we're going to use call just to call the procedure. Let's go scored above, and yeah, I mean, let's, or in fact, yeah, let's say maybe 7,000. Right, so 7,000, wait, it should just return these three. So yeah, let's try that. No. Okay, so what happened? Okay. Alright, so yeah, what kind of stupid mistake have I made? Alright, yeah, super stupid. Alright, just kind of forgetting the 0. Right, now hopefully, yeah, okay, so there we go. And of course, because this is greater than or equal to, well, it's also going to output Alice. Now, if, if of course we made this greater than, well, yeah, now we see Alice just disappears. Okay, so far we've looked a lot at 1D arrays. However, for the exams, right, both IG, AS, A2, you will also need to know about, well, 2D arrays and also, possibly even more dimensions, right? So 2D, 3D, 4D, yeah, just general sort of multi-dimensional arrays. So, I mean, just to recap, well, a 1D array is just going to be a list, right? But we can think a 2D array, I mean, basically this is going to be a grid. So, in fact, maybe if I just exit this, and yeah, let's just load up Excel or something. Right, let's try, yeah, okay, let's just go in here. Now, for example, a 1D array, we can just say, let's say like this, okay, I mean, here we've got, what, 6. Now, if we're thinking, well, a 2D array, right, we're gonna, well, we're gonna have columns, right, but then we're also gonna have rows as well. So, for example, this one here, well, this will be 1, 1, right, this is going to be 1, 2, 1, 3, right, etc. And then, of course, here, 2, 1, all right, 2, 2. And the thing to note is that, well, in maths, we say x, y, right, so that means, we kind of go horizontally first, right, and then we go y, so, y is the vertical, right, the y-axis. Whereas, for arrays, for programming, we actually go the other way, right, so the first number is going to be the row, right, so, I mean, here this means row 1, column 1. The next one, well, this is row 2, column 1. And in fact, yeah, let's just zoom in a bit. Right, whereas, obviously if we look at this one here, well, this is row 1, column 2, row 1, column 3. Alright, so, I mean, the thing I was taught, well, just remember RC, so row then column. Now, I have seen, a few kind of acronyms or something that people use to remember this. So, yeah, I mean, well, one you can remember, Roman Catholic, so I guess the religion. Another one I've also seen, well, just remote control. So kind of like an RC car, right, remote control car. But yeah, just remember, right, rows first, then columns. So if we go back here and let's just make this full screen, right, the first task we want to do, right, this is going to be about pixels. So if you don't know, well, an image, or specifically a bitmap image, right, we can represent as a 2D array of pixels. So that means, well, we're going to have rows, right, because an image is going to have rows, right, and then, well, an image is also going to have columns as well. So if we just start this, let's say declare, all right, then, well, the syntax is just the same. I mean, let's call this maybe image or pixels, I guess. Right, and then so the thing that's different is here, well, there's going to be sort of, you know, 2 dimensions basically. So the first one, let's just say we want maybe a 1x3. So this means there's going to be 3 rows. Right, and then let's say our image here is going to have 2 columns. Alright, so in this case, yeah, our image, well again, right, so 1, 2, 3, right, 3 rows, and then 1, 2, so 2 columns. So yeah, I guess you can say what the resolution is going to be, you know, 3x2. Right, and then however, let's also say that we also want to store the individual, you know, red, green, blue color components. So if we think that, right, RGB, well, RGB, there's going to be 3 components, right, because, well, red, green, blue, so 3. Right, and then let's say here, we're going to say this is of the data type integers. And I mean, the reason for this is, if you don't know, right, each of the RGB values has to be, well, between 0 and, let's say here, right, so 0 to 255. Yeah, and I mean, these can only be integers, right? We can't have a real number for the pixel value. Right, so in order to actually represent this, or sorry, in order to assign this, let's go pixels. Now we could go like this, so we say, right, row 1, column 1, and let's say pixel 1, sorry. Right, so row 1, column 1, and then color 1. So, you know, the color component, well, this means red basically. So if we want red, maybe 200, alright, you know, we would just say like this. So this would mean 200 red, yeah, in the sort of top left pixel, or yeah, like row 1, column 1. You know, then of course we maybe go 240 green like this. However, well, probably you can see, right, this is going to take quite a long time. So what I'm actually going to do, I'm just going to use the shorthand, to be honest. And you know, we could also just assign them random values, that's also fine. However, here, let's say we don't want to use random because, yeah, we actually want to kind of easily see values so that we can test them. Right, so what we can do then, let's say here, so this is going to be our array. And then what we're going to have 3 rows. All right, so let's go 1, 2, and 3. All right, so these are our 3 rows. Then inside here, we're going to have 2 columns. Right, so yeah, 2 columns for each row. Right, and then so I mean, basically this will be 1 pixel, right? Because this here, well, this is row 1. Right, then this is, well, row 1, column 1, and then row 1, column 2. Right, likewise, of course, well, row 2. So yeah, well, you know, row 2, column 1, row 2, column 2. Right, but then we say each pixel, these are also going to have 3 values, right? Red, green, and blue. So let's say for the first one, maybe 240 red, say 220 green, and 0 blue. Right, and I'm just going to fill these out quickly, maybe 90, 50, 70. Let's say maybe, yeah, let's say 0, 20, 30. Let's say 240, 255, 255. Maybe 15, 25, 35. And maybe here, let's just go somewhere in the middle, maybe 150, 100, and yeah, 180. Alright, so I'm just going to run that, just check there's no errors. Yeah, okay, right, so it seems the dimensions are correct. Now, let's say we just want to loop through each pixel and output these specific pixel values, you know, for that actual pixel kind of location. So what we would want to say is sort of like, you know, row 1, column 1, and then we say red equals 240, green is 220, and blue is 0. So yeah, we just want to output the pixel information. So in order to do that, well, like a 1D array, we just use a loop. Right, but here, because we've got 3 dimensions, we're actually going to need, well, 3 loops, right, all kind of nested loops. So in order to do this, well, let's go 4. I mean, you know, you could just call it sort of D1, like dimension 1. However, I'm actually just going to call it rows, or yeah, maybe row, because, well, generally we think of this first one as, you know, being the row. So right, this is going to start at 1, and then let's say 2. And again, of course, well, we could just say 3, right? We could hard code it, but we can actually just go length, and this will be the length of pixels. Right, then the next one, this will be the column. Again, this is going to start at 1. And I mean, okay, let's just explain this, right? So here, the length of pixels, well, what that means is, you know, basically here the length is 3, right? Because sort of the first level of arrays, we've just got 3. So yeah, obviously, well, 1, 2, and 3. Right, now obviously there's going to be sub arrays inside this, but yeah, the kind of first level length, I guess, is just going to be 3. Right, so if we look at the next one, this is also going to be pixels, but here we actually want the length of each row. So let's say here, well, you know, this row, right, this is going to have a length of 2, because, you know, here we've got, well, column 1 and then column 2. Alright, so hopefully you can see that inside each row, yeah, the length is going to be 2. Right, so I'm just going to say this will be pixels row. Alright, because for example here, well, yeah, length of, well, pixels 1, or yeah, pixels row 1, right, that's just going to be this one. Of course, pixels row 2, right, that's going to be this one. And yeah, pixels row 3, right, well, that's going to be these here. Right, now, actually this inner loop we actually don't need for our particular output statement. However, I mean, let's just do it just to demonstrate. So here, let's say maybe pixel color. Or we could say, yeah, color component. Right, and then here, that's going to start at 1, then we go to length, and this is going to be pixels, and then row and column. Yeah, so that should be fine, because if we think again, let's say row 1, column 1, well, that's going to be this here, right, and then the length is going to be 3, right? Let's say row 1, column 2, well, again, the length is going to be 3. So if we just output this, so let's say we want to output pixels, and here it's just going to be, well, row, column, and then pixel color, right? And then we just have to remember next. So let's go next pixel color, then let's go next column, and let's go next row. Right, and then here I'm just going to output like this, just so we can separate them. All right, yeah, let's see if this works. And yeah, okay, so we see what we've got, kind of 240, yeah, 240 red, right, 220 green, and 0 blue. All right, so that's working. However, I'm actually just going to comment this out. So yeah, I'm just going to modify the output a little bit. All right, so what I'll have, let's say maybe row, then let's go, all right, let's just have the comma like this. Let's say column. All right, okay, yeah, then let's have the colon, and then I think I'll just go like, you know, R equals 240, you know, G equals 220, all right, like this. Right, so this first one then, I mean, because here we can actually hard code them, right, because the first one we always want to be red. So red is going to be, you know, index 1 here, obviously green index 2. So yeah, let me just copy this. Yeah, maybe something like this, right? Let's go green, and that is going to be index 2, and then yeah, let's copy this one, and okay, let's go B, so blue, right, that's going to be index 3. Right, and then let's just delete this kind of separator here like this. Alright, so I think that should work. Right, did I forget? Okay, I think here. So yeah, I think here I've just forgot the ampersand. Alright, let's try again. Maybe I forgot more. Okay, wait there. Yeah, okay, it seems I've made lots of mistakes, and I guess I just copied the mistake over and over. Okay, there we go. So yeah, what this is saying then, well, row 1, yeah, row 1, column 1, of course these are the values, all right, row 1, column 2, yeah, row 2, column 1, all right, etc. So what we want to create is a function, right, or well, procedure, that's just going to kind of update the brightness of these pixels. So in order to actually update the brightness, all we're going to do is, well, just, you know, plus or minus a value for, you know, each of the color components. All right, so for example, let's say if we want to like plus 50, so we want to make each pixel 50 brighter. Well, then we're just going to, you know, plus 50 to this, right? So plus 50 to the red, plus 50 to the green, and plus 50 for the blue. However, you have to remember that, again, we said, well, the range has to stay within 0 and 255. So, you know, this shouldn't go to 290, right? It should be kind of clipped at 255. Yeah, you know, meaning it won't be able to go higher than that. And likewise, if we're kind of reducing the brightness, so making it darker, well then it, you know, it won't be able to go below 0. So let's actually, yeah, maybe let's just put this inside a procedure, and then let's call it maybe print, yeah, print pixels, or maybe, you know, print pixel information or something. Right, yeah, well, so just so we can call it, you know, when we want. Right, let's call it print pixels, and let's say before this, right, let's, yeah, I guess, well, let's create it first. Right, so let's say here, procedure, this can be change brightness. And then if we think, well, this will take a parameter, which is the amount, right, so this can be, you know, positive or negative. Right, let's say integer, and right, end procedure. So here actually, I mean, I'm just going to copy this code because we just want to loop through, you know, each pixel value. Right, so yeah, looping through the rows, columns, and then the, you know, pixel colors. Right, this time I actually will uncomment this, and yeah, let's also uncomment this. Right, okay, I'm going to remove this one, and yeah, let's delete this. Now here we don't want to get 1 because, well, 1 will always be red. So here let's actually use the variable, which is the pixel color. Right, because again, this pixel color, well, this will go, you know, 1, 2, 3, right? So just going from yeah, red, green, blue. Right, and then what I'm going to do, I'm just going to copy this. And then what we'll do is we'll just go plus amount, because if we think, well, if the amount is 50, then of course it's going to add 50, right? If the amount is negative 50, well, you know, then it's going to kind of subtract 50. Right, however, well, in fact, yeah, let's just see that, see if it works. So we will call, right, let's, okay, there we go. Right, let's go change brightness, and let's try 50. So at the moment, right, this will actually go to 290, which, I mean, well, really, that's not what we want, but yeah, let's just see if it works. Yeah, okay, so it seems this is working. Right, now we need to think then, how can we kind of, you know, keep them within the range 0 to 255? Yeah, so I'll let you just have a little think about that. Okay, so hopefully this one is not too difficult. So I mean, actually we can do this just using, you know, a couple of if statements. Right, so let's go here, and then let's say if, right, then we just want to paste this, and we'll say if this is greater than 255. Right, well, I mean, then we're just going to set it back to be 255. Right, so, you know, if this is like 290, well, 290 is bigger than 255. So, yeah, then we'll just assign 255, you know, back to this. Right, and then I'm just going to copy the same thing. And here, let's go, right, let's go 0, and then this should be less than 0. And then here, we'll just assign it to 0. Alright, so that should work, so let me just run that. And yeah, okay, so you see, well, we add 50 to the brightness, right? But you know, this one gets kind of clipped at 255. Now let's say we want minus 50. So I guess this one here is 0, right? And you know, this is just going to stay at 0. Likewise, so I mean, these here, right? They're all going to be 0. So yeah, let's try and run this. And yeah, okay, we see, and yeah, okay, also this one too, right? They're also all 0s. Alright, so I think, yeah, I mean, that one seems working fine. Obviously this one is a bit complex because, well, I mean, here we've actually got, you know, 3 dimensions, alright, which is probably, yeah, probably more than they would do in the exam. I mean, like 2D arrays definitely for IG, AS, A2, right? I mean, they always have 2D arrays. 3D arrays, you know, less common, but I guess they could ask it. Alright, so yeah, let's just have a look at the final challenge. So I'm just going to delete all of this. Right, and I think, yeah, actually this one is a little bit easier. You know, maybe I should have done this one first. So here then, well, we just want an array to store details about employees. And I mean, the details we want is going to be email, right, name and telephone. Right, then the features, well, one, we want to search by email. So, I mean, basically just linear search. And then I guess, you know, if we search by email, right, then it's also going to output, you know, their name and telephone. right, then we also want to find all employees of Bell Labs. And I mean, yeah, I guess I can just show you. Right, I mean, so here I've actually got all the data because, oops, yeah, because, well, otherwise it's going to take, you know, a long time for me to type this out. Right, so yeah, let's think about how we can do this then. So let's go declare, and we'll say employees. Now here, right, we're going to say array. And yeah, well, again, you know, we need to think of the data types. Yeah, well, the data types and dimensions. So, I mean, let's say here, right, I've just got 7 employees. And if we think the dimensions, well, we've just got 3 columns, right? So if you think 7 employees, that's going to be 7 rows. And then, you know, each employee has like 3 things of data. So yeah, that's going to be like 3 columns, right? So, I mean, for the dimensions, I guess we can just go, yeah, 1, 7, right, and then 1, 3 like this. Because, well, 7 rows, 3 columns. Now, I mean, now we just want to think of the data type. So I know some people might think, well, telephone, right, that can be integer. But the problem is, well, I mean, I guess there's kind of 2 problems, right? One, you know, sometimes telephones, you know, maybe you have some kind of plus symbol, right? You have the brackets. Yeah, you might have like the international sort of country code, right? And then, I don't know, maybe you have some sort of hyphen or something as well. All right, so obviously, yeah, I mean, this can't really be stored as an integer, right? There's also another problem, like if you have, say, you know, some huge telephone number, and I think some telephone numbers, you know, can be maybe 12 or 14 digits, you know, depending on the country. Now, the problem is, you know, I think this will be bigger than the standard integer in a lot of programming languages, right? Because well, you know, a standard integer is just going to be 32 bits. And, you know, if we just output that, that's going to be 2 to the power of 32. Yeah, I mean, well, let's just run this. Okay, alright, so I guess I've got an error because of this, probably. Yeah, so, I mean, basically, you can't have a phone number that's, you know, sort of bigger than this if you're storing it just as a regular integer. Now, you know, okay, going off topic, but many programming languages also have, like, a sort of yeah, maybe like a long integer or kind of like an extended integer, for example, which will be 64 bits. And of course, yeah, then it can get bigger. All right, and well, then you can have sort of like arbitrary length numbers, which can just be infinite size. Yeah, but that's kind of going, you know, beyond the scope. Right, but anyway, so the key point then basically is, well, telephones, we can't store them as numbers, right? They're going to have to be stored as strings. And then, right, and again, you know, we could just go like this. So we could go employees and then like this, and then we just have, you know, so this here, right, this can be the name, let's say Ken. The next one can be, let's say the email, you know, right, Ken at Bell Labs, or yeah, I guess here maybe the other way around. And then I guess, yeah, the third one can be, you know, the telephone number. So we could do it like this for all of them, right? But I'm actually going to use the sort of syntax that Cambridge prefers, which is when we're actually like manually specifying, you know, the sort of indices, right, for yeah, for every dimension. Right, so right, let me just copy this, because yeah, otherwise that's going to take too long to type out. Right, so when we've got this, then let's say first we can maybe just, again, let's create a function or procedure just to output all of the employees. So, I mean, again, I'll give you sort of 10 seconds, just pause the video, right, have a go at this. And of course, you know, you can do it just for like 3 employees, right? I mean, yeah, don't choose 7. Okay, right, so let's just have a look at how we can do this then. And I'm just going to move that down a bit. Let's go procedure, let's say, yeah, I don't know, like print employees, or let's say print all employees. Okay, actually, all right, what I'm going to do, so I'm going to have 2 procedures. So one procedure just to print 1 employee, and then there'll be another procedure called print employees, which basically will just loop through all the employees, and then, yeah, call this print employee for each employee. So, I mean, if that doesn't make sense, well, let's just get started. Right, so this one should just print the details for 1 employee. So we want to think then, basically, well, we want to give it all of this information, right? So basically you can think, you know, we just want to give it the whole row, because if we give it the whole row, well then the whole row, yeah, the whole row is going to contain all of this information. So yeah, let's say this can be employee, right, and then let's say this is going to be an array of string. And again, basically, well, this will just be one row, right? So like the 3 columns effectively. Right, let's go end procedure, and again, we'll just loop. Okay, actually, yeah, let's not loop through, because we're actually going to want to specifically print sort of like email, telephone. Alright, so I'm just going to kind of make it, yeah, maybe make it look quite nice. Right, so here let's have maybe some hyphens. Let's go, yeah, maybe employee. Alright, then we can have the name. Right, so the name then, if we think that's going to be employee, and then here, right, the name is actually index 2. And okay, actually, so here's a question. See if anyone can write in the comments. Like, does anyone know who, yeah, who all of these people are? So obviously, you know, kind of fake email addresses. But yeah, I mean, they do actually kind of reference famous people. So yeah, like if anyone knows who they are, right, just leave a comment. And then yeah, I mean, see if you're correct. Right, so let's say here then. Yeah, okay, so we'll just have that. So just a kind of header, just saying the employee and then the name. Right, now we could actually go like this and then sort of type like email, for example. However, I'm actually just going to output on a new line, right, just to make it look a bit easy. I guess maybe, yeah, make it easier to understand. Yeah, I mean, or I guess maybe here let's have a couple of spaces or something. Right, let's say email. Yeah, okay, maybe. Right, so the email, if we look here, well, that's going to be index 1. So here then we can just go employee, and this is index 1. And then for the final one, we can just say phone. And right here, it's just going to be index 3. Now, I think that should work, and you know, we can actually try this. So let's say call, and was it print employee? And I mean, I don't know, let's say we just want to, you know, print number 1. So here, let's say employee and index 1. So again, right, you know, this is a 2D array, but if we just go employee 1, well, that's just going to get one of the rows. And then, for example, you know, if we went to say like 1, 3, well, that's going to get, you know, row 1, column 3. But yeah, like, I mean, looking at this, right, this is going to require the whole row. So yeah, I think this should work. So let's test it. Right, employee, okay, so this should be employees. And yeah, okay, and actually let me just delete this \n. Or yeah, I guess maybe I'll keep it. Alright, and then I think what I'll do, let's also just output some like sort of new lines here as well, just to separate them in a minute. Alright, so I mean that's pretty good, but then let's say now we want a procedure just to loop through and, you know, print out all of them. So what I'm going to do, let's say procedure, maybe print all employees. Right, this doesn't need any parameters, and if you think, well, here we just want to loop through the rows. Alright, so for example, we go for, let's say n, or you can call this employee number. Right, and this is just going to be the length of employees. So again, here, the length is just going to be 7, right, because it's always, you know, the first dimension, that's the length. And then yeah, inside each of these kind of first arrays, well, then we're going to have kind of like a sub array inside that, basically. I suppose, well, yeah, not really a sub array, but yeah, I mean, in this case, it's just a string, right? There's no, there's no sub array. Alright, so anyway, let's say here then we go next n, and here we're just going to call the print employee, and the employee is going to be employees and then index n, because again, right, this will just print, well, you know, employee 1, employee 2, employee 3. So let's try this, and yeah, okay, I mean, let's just run that. Okay, and well, let's just forget to call it as well, because I think that's an easy mistake to make. And yeah, okay, so we get that, which, yeah, I mean, I guess it kind of looks okay. You know, the formatting is not really that important. All right, let me just delete this maybe. Yeah, okay. Alright, so yeah, I mean, obviously that doesn't really matter. Alright, so what we then want to do, we want a function, or procedure, which is going to allow us to search by email. And then I suppose here we just want it to output. Alright, so if for example they search like Dennis at Bell Labs, right, well then it's just going to output like these details basically. Right, so let's just make this, I mean let's make it a procedure, because we don't really want to return anything. Right, so let's say maybe get, I mean we can call it maybe search by email, or search employee by email. Right, so here this is going to take an email address, which is just going to be a string. And then again, let's go end procedure. And then if you think, I mean basically linear search, right, we just have to loop through. So again, let's go for, right, go 1, 2, and then this is the length, right, the length of employees. And then what we can then just do, right, let's say if, so we're gonna say, right, okay, so we see column 1 is the email. So what we'll say then is if employees, right, it's going to be row n, and then let's say column 1, and if this is equal to the email, right, then what we're going to do is we're just going to go print, and the employee we want to print is just going to be employees n, right, because this is the current employee that we're checking. Then let's just end if, right, next n, and I think that should work. So maybe I'm just going to comment this, right, otherwise it's going to be a bit confusing. Right, then let's just go cool, and what we call it, search by email, and let's try, maybe let's try this one, so Tim, and okay, if we just run this, let's see if it works, and okay, so we see, right, that successfully works. Now if we try, I don't know, like, Timmy or something, and again, obviously, right, there's no matches, and again, right, if we do want to maybe output a message, right, let's just go declare, let's say found, right, this can be Boolean, and if we found it, well, let's say found is going to be true, and like honestly, we could initialize it, we could initialize this to false, right, however, I mean this will actually happen automatically. But I guess for Cambridge, right, they would actually want you to do this kind of explicitly. Right, and then again, we're just going to say if found equals false. Right, then we're just going to output, and this can be no employee with the email, and then let's just say the email address that they typed in. And I mean, I guess sometimes, right, they can also, I mean, so you could also make this an integer, right, and then, you would return the count as well. However, I guess in this case, like, you shouldn't really have 2 employees with the same email address. So, I think here we can just make this, either found or not found, right, just a Boolean. Although, before I have seen exam questions where they kind of want you to count, like, kind of how many searches it found, basically. How many matches it found. And okay, so we can see this works here. Right, so okay, so I think just the last one then. So now we just want to find all the employees of Bell Labs. Now, I mean, in other programming languages, this can be quite easy, because, well, they have function like ends with, right, so to check if a string ends with something. So I mean, we can actually create that here, and I've not tried this before, but I mean, I think hopefully this logic should work. So let's say function, and we can just say maybe string ends with. Right, so for example, let's say let's say we have something like this, maybe like ABC, or maybe ABCDE, right, and then we're just going to check DE. So what this is saying is, well, does the string ABC end with DE? Right, and then, well, in this case it does, right, because, obviously the last character is a DE like this. So this should just return Boolean. I mean, that's basically the logic we're trying to go with. Right, so what we're going to say then, this can be maybe the, I don't know, subject or something. or yeah, maybe this can be the original, and then I don't know, yeah, let's call it end or something. Right, and then if we think this is going to return a boolean, and I think the logic we want to do, I mean, well, again, I'll give you time to think, right? But yeah, just think about which of these string manipulation functions we could use. All right, I mean, or we could also do this, probably just do this using a for loop as well. Right, so I think, I mean, well, like my logic is that we can just use the write function. So let's say here we can just go, and I mean, we could go if like this, but I think we can actually just go return. And let's say write, and we want to check the if write of the original, right, and then we just want to get the length, because for example here, right, if you remember, if we do something like write, again like ABCD, and then we go 2, well 2, this is just going to return DE, right, so it's getting the the 2 kind of characters like starting from the right. So yeah, I think what we want to do then, we want to get the length of this end, because for example, if say they pass in, well, cern.ch, well here the length is going to be 7, right, because we've got to remember this dot. All right, so yeah, there's going to be 7 characters here at the end. So then if we just go, kind of write of the whole email and then 7, right, that should just, get these characters. And then I guess we just check that if they are equal to this. So let's say length, right, this is going to be, yeah, the length of end, and then we just check if that is equal to end. All right, now I think that logic should work. Let me just test that. So let's go output, and yeah, where did I call, okay, let's just comment out this. All right, so here, let's say output, let's go string ends with, and again, let's just try something simple, ABCDE, let's go DE. Right, so this should return true, hopefully. Yeah, okay. I mean, let's try like DEF, so it should be false. Yeah, okay. And let's try, I don't know, maybe CD. Yeah, okay, also false. Right, so I think, I mean, this logic seems to be working. Right, so if we go back then, what we want to do, we want to find all emails that end with Bell Labs. And specifically, we're actually going to want to include this @ symbol as well. Because, what if there was another company and maybe it's like, yeah, the Bell Labs or something. Well, obviously, yeah, the Bell Labs is going to be different from, Bell Labs. So, whereas if we also include this @, right, well, this means it has to be, the full kind of domain name. Right, so, yeah, so what is it we want to do? Right, okay, so, yeah, let's just make another procedure then. Yeah, I mean, let's call it maybe get in, yeah, print employees, of company or something, or print employees, with that email domain. So let's say here we'll say like email domain, or yeah, email domain name. All right, that's going to be a string. And let's go end procedure again, right, and then again it's just going to be the same logic. So just loop through, right, 1, 2. That's going to be the length of employees. Right, then we'll just go next n, and here then we just want to, well, we want to call this function. So I think we can go if, and let's say string ends with. Now this is going to be employees, right, then it's going to be row n, right, and then it's going to be, okay, column 1, right, so column 1 is the email address. Right, so we check if this string ends with, right, and then here let's go the @. Right, so we also want to concatenate this @, and then let's just go the email domain. So yeah, okay, and then let's go what equals true, right, although we actually, again, we don't actually need this equals true, because I mean this whole thing is just going to return a boolean, right, this whole thing is going to be like either true or false. But again, let's do it just to be explicit. Right, let's go end if, and then I guess here that, and then we can just go print employee. And then, right, so what parameters, this just takes, yeah, this just takes the employees, right, and then the row. Right, so I think that should be okay. And let's just call this up here, so let's go call, print employees of company, then it's going to be, yeah, Bell Labs, and just check I spelled that correctly. Alright, so yeah, I guess now, well, let's just see if it works. Kind of. Yeah, I mean, okay, so this is correct. Like, why is this, yeah, why is that wrong? Alright, so yeah, I just looked at it, and well, I mean, basically I found the cause of this little error here. And I mean, as we can see, right, I mean, the code is actually working, but yes, it's a little bit annoying we're getting this. So the problem is then that if we look at some of the actual data, for example, this one, well, this one here, I guess, just has a length of 11, right? So tim@cern.ch. Now, if we look at what we're checking, well, right, so here we're checking, well, belllabs, .com. This one here has a length of 13, but then we're also concatenating, or yeah, kind of like prepending, right, prepending, this like this @ symbol. So yeah, I mean, that's why it gets the length of 14. So the problem is basically that, well, this end, like in this case, this end is longer than the original. And then here it's saying, well, right, the original here is going to be, the original is, 11 characters. And I guess, well, then we're saying get 14 characters from the right, like of a string that only has 11 characters. Which is obviously kind of invalid. Alright, so I mean, the way we can actually solve that, well, basically we can just have an if statement, so checking that if this string is longer than the original string. So let's just do that. Let's go if length of end, right, and then we're going to check if greater than original. Now, I mean, we could honestly also do greater than or equal to the original, because no one should have an email address that doesn't have anything before the @ however, I mean, let's just sort of check greater than, alright, because I guess we don't really need to worry about validation. And alright, this also should be length of original, right, and then if if this is true, right, I mean, then we can just return false. And yeah, I'm just going to delete some of this stuff. Alright, so now hopefully this error should disappear, because again, let's say if the length of this end, so here, what, 14, so if 14 is greater than 11, right, then it's just going to return false. Because, for example, obviously, like if the email address that we're checking, right, is longer than the actual kind of original email address, well then, like, obviously that obviously it can't be the correct kind of domain, right, or it can't be the correct company. Alright, so yeah, let's just run this, and yeah, okay, so here we get the correct data, and you see no error. Alright guys, so I'm not sure how long that video's been, probably close to 2 hours now, I would have thought. But yeah, hopefully that's been useful. Right, we've covered a lot, right? 1D arrays, 2D arrays, linear search, bubble sort. So again, hopefully it's been useful, right? Any questions, like, again, just ask in the comments. Send a message, on the website, right? Send an email. And yeah, hope to see you in the next video.